we have a theme going relative to the Model 3 and the new Semi, and the theme focused on the fact that Daimler's executives in different continents had suggested that Tesla really couldn't compete. The quote that I gave you at the front of this was sort of in that theme. So today's sort of focus is one to sort of review sort of latest development on that piece, as well as to jump into something called torque vectoring, which we may start as a conversation now and extend going forward. So for those of you who don't know, one of the big question marks about Tesla is the fact that as trucks are being rolled out around the world, there was a question brought up by the executives at Daimler relative to Tesla's ability to provide all manner of services to those trucking clients, and the fact that Daimler has a global footprint that allows them to provide those services better than any other manufacturer in the world. And an illustration of that is that in the US they have 41% share when it comes to the largest trucks. Well, now Tesla has arrived in the electric space, and a few things have come up. One item, and we're not going to cover this heavily today, is the fact that when it comes to the highest weight trucks at 80,000 pounds and its ability to deliver that, now the only company that's shown an ability to deliver that and have prototypes running for customers to drive is Tesla. So the biggest issue is the battery technology facilitates this, because you have the problem right now for Daimler, Benz, Cummins, and other competitors, where the 18650 battery is just too heavy, so that when you try to put together a 300 to 500 mile truck on 18650 batteries, the weight is so great that it consumes too much of the freight weight of the vehicle, so that it's not economical to deliver at that level. So Daimler and others are sort of stuck at the 100 to 200 mile range vehicles when it comes to their batteries, and therefore they really don't have products at the highest level of Semi, which is the 80,000 pound capacity vehicles, which is where Tesla has decided to enter the market for a number of reasons, as we've covered in the past, and I'll put a link to it. You know, they're looking at the fact that 70% of freight in the world is hauled at the biggest level. The pollution that comes from those little trucks is the highest. So Tesla sort of zeroed in on that being a target, and really doesn't want to offer kind of mid-range products, even though it might be profitable to do so. So the aspect of, so we've covered some different looks at how Daimler argument against Tesla as a solution for their clients didn't make sense. And what I found interesting is that we did a review of the fact that Tesla has decided to do a fleet strategy for distribution of their trucks. The fleet strategy eliminates the need for dealership sales offices. And it also has the advantage of the fact that most fleets maintain mechanics, so that half the dealer sort of activities are already handled by the fleets, which Tesla doesn't have to pay to build an infrastructure for. The aspects of this I decided to look at today was what's going on the parts side. So if you look inside and outside the new Semi, you'll notice that the screens, the door handle, there are all these elements of the new vehicle that are shared between the Model 3 and the Semi. Now, I have to admit, I was looking at this and I thought that from what I call pimp my ride perspective, there are a lot of fleet owners that are going to want to change door handles and minor things that'll improve the form factor for the truck. But what's also fascinating to me is that there's this phenomenon happening where, because all those parts are shared between the Model 3 and the Semis, you now have an interesting prospect developing, which is around the globe where there are pre-existing Tesla dealerships or Tesla repair facilities and sales offices. Those fleets can now source parts for their trucks at the location of the repair facilities that are pre-existing. So what this therefore means is that Tesla has a global footprint for providing parts to all of the truck customers as they decide to roll out globally on this basis. So this is huge because in theory, the way things work right now is that if a company is building a truck and they're building cars, as is the case with, let's say, Mercedes-Benz, there's a huge problem because most, if not all, the truck parts are completely different than what the cars use. So a Mercedes truck can't really pull up to a Mercedes dealership of cars and say, we'd like to have some parts, and vice versa. The biggest issue with this is the fact that when you build a truck, 100,000 miles on a truck is average for a year. 100,000 miles on a car, particularly Mercedes, may be the life miles of that entire vehicle. So the way the parts are made, the nature of the parts, et cetera, are completely different. Now enter Tesla into the game, and they're introducing the concept of, wait a second, why don't we simply have the parts be the same, be it truck or car? And this is revolutionary because of a bunch of reasons. Number one, this facilitates the possibility that if other manufacturers follow suit, you now have the potential of people to get parts either at their truck dealership or the car dealership, which kind of doubles the footprint of where these parts might be available to be picked up by people in need of them, be it the truckers or the car people. So this idea, I think, is totally revolutionary, innovative. Number two, cost of maintenance of part supplies is going to go down because now you don't have to maintain separate parts depots. You can have the same parts being used in both places. Number three, economies of scale. One of the challenges that places like Mercedes have is if you have a very nice car with very few of those vehicles sold, the average part per cost per part is going to be up. So as I was reviewing this, one of the things that's always fascinated me about car repairs and impacting on resale values is the fact that when you look at Japanese vehicles, for example, because there are so many Japanese vehicles sold, the number of people that know how to work on them and the number of parts available tend to be higher versus some other manufacturers that have very few vehicles sold. So all of a sudden you have this parts inventory that's in motion that people can take advantage of, which you don't have if you have a very limited production vehicle that you're dealing with. So I'm kind of fascinated by how this is coming together because if you think this through, it sort of implies that Tesla kind of has a competitive advantage because they've got the largest footprint of superchargers combined with repair facilities and trained technicians with electric products. They globally have a better footprint, better solutions for customers in this space. And it's going to take years before others can catch up. And so kind of the way I see things going is parts are shipped to the repair facilities to handle Model 3s. Extra parts may be shipped there if there are fleets that need certain parts and they can pick it up from there or have it delivered to them. But now you can see what the average inventory is needed in that place and split it between two different types of vehicles. And I think this is amazing because you get all kinds of beautiful engineering economies with this that you do not get with how things are currently structured. So as I was sharing sort of at the beginning and with our thumbnail, Daimler is saying that Tesla really can't compete. And I think it's a yes that Tesla can't compete when it comes to building a diesel truck and competing with Mercedes-Benz globally. But Tesla is shifting the fight into the electric arena. And with things like the ability of parts shared across different vehicles, both truck or car, I think this is a game changer. And because of how smart the move is, not only I think is it going to influence how others are forced to deploy their electric solutions, but I actually believe that this move by Tesla could force a change across the entire auto and truck industry. Because now you're going to have reason or cause and cost good reasons why at the design stage and at the sort of delivery stage, you'll have all these manufacturers with a huge incentive to go ahead and wise up and deliver parts that can go seamlessly between solutions between trucks and cars. Um, I think that what will happen is people note this and make that change. I'm also intrigued by the fact that Tesla has been very closed mouth. Unless you're a buyer, you don't know a lot about what's going on with Tesla. And so I just find it interesting how this is breaking out, because Tesla's been very secretive with trucks unless you're a buyer. And I believe that the secretiveness of this goes to the point that it's not only an issue of does the vehicle work, it's also an issue of how do parts work? Does every aspect of what they're doing work, because they're re-engineering the process of how cars and trucks are built. And I think all those are competitive advantages that will have influence down the road to change how things are done. So again, yes, that Tesla or Daimler Benz is right that Tesla can't compete when it comes to diesel infrastructure globally. But when it comes to electric, Tesla already has a global footprint. And those customers can look forward to excellent service from out the box because of, one, how the vehicles have been designed, and two, how the network is set up with parts, et cetera, to support those vehicles. The next issue I wanted to get into is something called torque vectoring. So I kind of knew a little bit about this from writing and reviewing automobiles. In general, what I had learned in the old days, and it's kind of updated in this case for the Tesla truck, is just the whole idea that it turns out that if you have a four-wheel drive vehicle, and let's say you go around the corner, what tends to happen in that space is that each of those wheels now, if you optimize the speed in that corner, each of those wheels by computer technology may turn at different speeds, which facilitates optimal turning radius, etc., or stopping power, etc., of that vehicle. So Tesla is now bringing this to trucks by putting the base structure is 4 motors in the rear wheels on the tractor. And all of a sudden you have a beautiful setup where you've got all kinds of benefits from torque vectoring that comes from having 4 motors in each of the wheel wells of the tractor. You could actually do things like stop faster, turns can be more efficient, jackknifing issues will be reduced or eliminated, and therefore be safer for the truckers. So there's a lot of things that you pick up with a truck being able to do torque vectoring in this manner. There's a mystery that I think is interesting, which is in the case of Nikola trucks, they looked at putting 6 motors in. They're going to put electric motors in the front wheels as well as the rear wheels of the tractor. I mean, that's an extra 200 pounds worth of material that reduces your freight weight. And I don't know if you gain a whole bunch from it, maybe in a 4-wheel drive heavy snow situation, that might help. But it kind of seemed like overkill to me, but I thought it was interesting. It did bring up the concept of what if there was a decision made to, if you have an 18-wheeler, since you can throw in motors as you choose and the engine will drive them, might there be applications where you not only put in 6 motors in the front, but maybe a couple of different motors in the back of the tractor, so you can now establish control from the rear, all the way rear of the vehicle as those tractors are moving around. It doesn't cost that much money, not that much weight, but it's interesting the possibilities that electric opens up. So in the torque vectoring space, bottom line is that it's a cool name. The concept is basically that you get better stopping power, you get better turning radiuses, and you get literally better control of the vehicle, so the driver / computer can have better options for the safety of the vehicle and the driver. So I think this is pretty interesting stuff, and I'm sure everybody has to follow it because of how it works great for those vehicles, that cars that it's in. And there's no doubt that everyone in the trucking space is going to have to adopt this as well. So to close out, I wanted to thank you again for taking time out to visit with us. This is Greg for Tesla Fan Insight. Tschüss, macht's gut, au revoir, lehitrot, choda hafez, and look forward to all of your comments, especially respectful ones to other folks that might be on this page. Thanks once again for visiting us, and we'll meet at another time.